So in this lecture, we're going to see memory performance matrix. Okay. So memory performance matrix, it is the time to access one word. Access time, it is the time between the request and when the data is available or written. Cycle time, it is the time between requests. So bandwidth, how much data from the memory can be supplied to the processor per unit time. Okay. So classical RAM organization, this square is there. Okay. So here bit data line, this is the bit data line, this one, this black one you can see bit data line. Then each instruction represents 6 RAM cell. Okay, each instruction represent in this cell. Okay, here then word row line. This is the word row line in arrow show. Then column address. This is the column address. Okay, so data bit or word you can say one memory row holds a block of data. So the column address select the request bit or word from the block. So here column address is select by the request of bit. Okay, so these are the your diagram of you can say the memory or RAM organization of diagram here. So memory addressing bit operation. These are the diagram. Okay, so memory operation bit address here. Memory addressing. Okay, memory addressing. So let's see this. Okay. So here in memory addressing, first what is memory addressing? There are different kind of memory addressing technique, which are basically access memory word. Okay, different types of memory addressing are there, which are basically access memory word. So memory addressing, okay, basically access the memory word which are described that memory addressing. A memory address is the identifier for memory location where a computer program or hardware device can store data and later retrieve it. मतलब जहाँ data store होता है और retrieve होता है, that is the memory address. It is basically a binary number from a finite monitor sequence that uniquely describe the memory itself. In modern byte addressable computer, each address identifies a single byte of storage. So sample of the memory addressing is like address 3210. That is a G. It's represented in 11 binary number. Addressing strategy is coordinate address, like coordinate, coordinate address, right? Content address, content address. Okay, so coordinate address. In coordinate address technique, memory is accessed by some supplying a number of which is used directly to identify particular physical storage location. So here to identify the storage location, we use this. Okay, is accessed by the supplying a number which is used directly to identify a particular storage location where the data is copied into or out select location. In this case, coordinate address are typically constructed as collection of individual units, such as chips, each capable of storing a limited number of bits. Then, content address. Okay, next this is the content address. This is also called associative. It is accessed by supplying a data value for create portion of storage location. Okay, rather than the physical address of the location. 1 minute. Okay, so it is accessed by supplying a value for create portion. Okay, where the memory automatically identify any location that much given data and content of this location may be accessed. There are two registers are associated with content address memory. Okay, just 1 minute. Marks and data. When each register has the size of one full word, further each word includes some compression, compressed logic and one or more tag bits, where each set of tag bits forms a bit size register. Types of operation that may be possible on associative memories. Read and write. But the operation of memory that is read and write, search that is identify word that much particular pattern. Okay, read, write, search. Okay, so count matches. Count read, write. Here some operation are there like I'm writing here like this. Read and write. Okay, that is read, write. Then count matches. Count matches is there. Count matches. Okay, so this operation indicates how many tag bits are saved. Count matches is indicate the sets, how many tags are set. Then marks right here. Then marks right, marks right. In this, here write data from the data register into only the bits selected by the marks register. Then multi write, multi multi write multi-write here. In multi-write, write data into all text words at the same time. Then store. Store here in store. In store. In store. In store. Uh, write a data word into empty location rather than select one. Then address operation. Determine the coordinate address of a tag word read write by address. Okay, so register data and marks. Like bank addressing is there. The kind of techniques uses here bank addressing are there. Where it is? It's 1 minute. So in bank addressing, bank addressing in this in bank addressing, this kind of techniques uses high order bits of address to select units, where each unit represents a sequence of address. Okay, in bank addressing, bank switching assign different units of parts to the parts of memory to be used different purpose. Then interweaving this kind of technique uses low order bits of the address to the select units. Okay, so what is the memory management strategy? The strategy divided into several categories. Fetch strategy. Okay, so fetch strategy. In fetch strategies, demand and decide which pieces of data load next. Here, demanded or decide the which pieces of data to load next. Then placement strategies. In placement strategies here, decide where in main memory to place incoming data. Okay, decide to where to memory is placed. And replacement strategy here, decide to which data remove from main memory to make more space. मतलब यहाँ पे sometimes banking address में या memory management strategies में three types of strategies given like phase strategies, then placement strategies, placement strategies. That I'm writing here. Okay, that is strategies. Okay, and then replacement that is strategy. Okay, so in a phase strategy, this is demand or decide which piece of data to load. मतलब किस टाइप का data load करना है ये decide करती है phase strategy. Then placement strategy, it decide where in main memory to place incoming data. Okay, incoming data कहाँ कौन से location में place करना है, placement. And replacement means decide which data remove from main memory to make more space में मतलब मेन मेमोरी से किस टाइप का मतलब अनवांटेड डेटा या लॉन्ग टाइम डेटा जो यूज नहीं होता उसको मेक स्पेस करने के लिए रिमूव करती है, तो वो डिसाइड करता है विच टाइप ऑफ डेटा वी हैव टू रिमूव. ओके, सो there are different kind of addressing modes which are follow. Addressing modes से कुछ हम लोगों को we have to see some addressing modes. Okay, so first one is immediate addressing mode. So in immediate addressing mode, where the instruction itself contains the value to be used located in the address field of the instruction. In this addressing mode, the value is stored in memory immediately. मतलब value immediately stored होती है after the instruction, which is the similar to using constant in high level language. Advantages of immediate addressing is it is fast since the value is included in instruction. No memory reference to fetch data. Then disadvantage is also there in immediate addressing, that is it is not flexible since the value is fixed at compile time, can have limited range in machine which fixed length instruction. Operand is part of instruction. Okay, this is the immediate addressing having some advantages and disadvantages also. Then direct addressing. In direct addressing mode, instruction tells where the value can be found, but the value itself is out in the memory. Where the address field contains the address of operand, in this mode, effective address that is address field. In high-level language, direct address is a frequently used for things like global variable. Okay, that is the direct address. Then advantages is single memory referred to access data, more flexible than immediate. Okay, it is a flexible than immediate direct address. Then address field contain address of operand, effective address and address field. Then indirect address. Then indirect. Let's see. In indirect, memory cell pointed to by address field contain the address of operand. Okay. Add content of cell pointed by content of accumulator. Indirect addressing. Here, large address space there. Okay, maybe nested multi-level cascaded. Multiple memory access to find operand, hence load. Then register in this kind of addressing mode, operand is held in register name in address field, that is EA equal to R, where the limited number of register, which very small address field needed. Shorter instruction and faster fetch. So in this, no memory access, very fast execution there, very limited address space there, multiple register help performance, require good assembly programming or compiler writing. Okay, so there are limited number of register, a very small address field is needed, shorter instruction, faster instruction fetch. No memory access needed to fetch. Okay, very fast execution there. Okay, then register indirect address also there. In this kind of addressing mode, where the operand is memory cell pointed to by content of register. Okay, then this displacement addressing there. In this addressing mode, where the address field holds two values, that is base value and register that holds displacement, or vice versa, which combines register indirect address and direct address. So this displacement addressing, that is a combination of direct and indirect. Okay, so address field holds two value, base value and register that holds this displacement, that is direct and indirect. Then relative addressing is that it is the another version of displacement addressing, where the programmer counter, that is get operand from cell from current location. Okay, then base register there, where holds displacement, register holds pointed to base address. Okay, so here stack also there. The stack addressing is a operand is a top of stack, that is pop top two items from stack and add, means adding and removing, pop and push. So describe the addressing Pentium process is there. Pentium. Virtue of effective addressing is offset into segment, where starting address plus offset linear address. Okay. Then a 12 addressing mode available: immediate, register operand, displacement, base with displacement, scale index with displacement, base with index and displacement, base scale index with displacement relative. So indirect instruction includes 16-bit displacement to be added to base register. Indirect index instruction refers base register and index register. Branch address, absolute, relative, and indirect. Arithmetic operands in register or part instruction, floating point register only. Instruction format, the basically describe the layout or bits in instruction. This also includes opcode. It also includes operand. Instruction length, which affected by and affected of the memory size, memory organization, bus structure, CPU complexity, and CPU speed, which is also trade-off between powerful instruction and saving space. Allocation of bits, that is number of addressing mode, number of operand register versus memory, number of registers set, addressing range, and addressing. Okay. So memory hierarchy here, you know very well, two types are that temporal and spatial. Okay, temporal, which keep most recently accessed data item closer to the processor, and spatial, which moves block consists of continuous word onto upper level, right? Where the neighbors of data or instruction that was recently accessed are likely also accessed. Okay. So we have seen the memory register hierarchy of memory, right? So general principle of memory hierarchy is that how fast it is, how much capacity, how much expensive, which we have seen, right? So this is all the principle. Okay, then okay. So this lecture over here. So now we're going to see the RSC and CIC. So here, architecture of these. The architecture of the central processing unit, that is CPU, operates the capacity of function, means it's operate the capacity of function from instruction set architecture. Okay, this operates the capacity of function. Okay, from where what? Okay. Okay. So the architecture of the central processing unit operates the capacity to function. Okay, operates the capacity to function, not of from the instruction set architecture to where it was designed. The architecture design, this architecture is designed where it is. The instruction set architecture to where it was designed. The architecture design of CPU is reduce instruction. CPU is reduce instruction set computing, that is RIC. Means the architecture of CPU was designed RIC, that is reduce instruction set what computing RIC. And what one more is there, which one? And that is complex, C for complex instruction set computing. Okay, so the architecture of CPU is designed where in RISC, that is a reduced instruction set computing, and CIC, that is complex instruction set computing. Okay, a processor like CISC has the capacity to perform multi-step operation or addressing modes within one instruction set. It is the CPU design where one instruction works several low-level acts. For instance, memory storage, loading from memory, and arithmetic operation reduce instruction set computing in a central processing unit. Design strategy based on the version that basic instruction set gives great performance when combined with microprocessor. It gives the great performance when it combined with microprocessor. Okay, instruction. So this architect discuss the difference between RIC and CIC architecture. The hardware part of the internal name complex instruction set. The hardware part is named complex instruction set computer, that is CISC, and the Apple hardware is reduced instruction set. Okay, so what is RIC? What is reduced instruction set complexity? So a reduced instruction set computing a computer is a computer that only uses simple command that can be divided into several instructions that achieve low-level operation within a single CLK cycle. As its name proposes, reduced instruction set. The RISC is a reduced instruction set computer microprocessor, and its architecture includes a set of instructions that are highly customized. The main function of this is to reduce the time of instruction by limiting as well as optimizing the number of commands. So each command cycle uses a single clock cycle where every clock cycle includes three parameters, namely fetch, decode, and execute. Okay, here three parameters include fetch, execute, and decode. The kind of processor is mainly used to execute several difficult commands by merging them into simple ones. RISC processor needs a number of transistors to design, and it reduces the instruction time for execution. The best example of RISC processor include PowerPC, then microchip, PIC, and processor etc. The example of RIC is microprocessor, then PIC processor, then chip, microchip. Then advantages of this that means in RIC's advantage is that the performance of the processor is good. because of easy and limited number of instruction set. This processor uses several transistors in design, so the making is cheaper. RISC processor allows the instruction to utilize open space on microprocessor. Due to it is a very simple as compared with another processor. Due to this, it can finish its task within a single clock cycle. Then what is CISC? Okay, it was CISC, you know very well now, CISC, complex instruction set computer, yeah, computing. So it was developed by cooperation and it is a complex instruction set computer. This processor is both as a processor, okay? This processor includes a huge collection of simple to complex instruction. These instructions are specified in the level of assembly language. You know very well now assembly, right? And execution of this instruction takes more time. A complex instruction set computer is a computer where single instruction can perform numerous level operation like load from memory, arithmetic operation, memory store, accomplished by multi-step processor or addressing mode. In single instruction, as name processor is a complex instruction set. So the processor move decrease the number of instruction on every program and ignore the number of cycles for each instruction. The characteristic of is that CIC may take more time to execute the code as compared with any only clock cycle, right? It take a more time. That is the characteristic of this CIC. Then CIC support high level language for simple complication and complex data structure. It support the high level language. So this is the one of the characteristic also. It is collected with more addressing nodes, fewer register, normally from 5 to 20. For writing an application, less instruction is required. The code length is very short. In CIC, the code length is short, is good advantages and characteristic. So it needs extremely small RAM. It highlights the instruction on hardware while designing as it is faster to design than software. Instructions are larger as compared with single word. The advantages of is CIC includes following advantages, that is this processor will CISC, that is complex instruction set. It is also processor. So we can say that this processor will create or produce handle the use of power. A single instruction can be executed by using different low level tasks. So here it does not use much memory. In CIC, this processor does not use much memory due to the short length of code, because it's need only shortcuts, so memory wasted will be not there here or not there. Okay. CIC utilize less instruction set to execute the same instruction. The instruction can be stored with RAM on every SIS, that is on every processor. So here the advantages of these, difference between is that RISC, that is you know very well now, RISC is a nothing but reduce instruction set computer, and the difference between you can say that CIC is a stand for complex instruction set computer. Then RISC processor has simple instruction taking about 1 clock cycle. The CIC processor has complex instructions that take up multiple clock for execution. Performance is optimized with more focus on software. In RIC, the performance is what optimized with more focus on software. In RIC is focus only software, but in CISC, the performance is optimized with more focus on hardware. So this is a different also full form, you know very well now, RIC and CIC. Then means what now here if RISC is focus on software and the CIC is performance focus on hardware, then it has RISC is has no memory unit and use separate hardware to implement instruction, but in CIC it has memory unit to implement complex instruction. Okay, and then in RIC it has hardwire until unit programming, sorry, hardwire unit programming here, and in CIC it has micro programming unit. So in RIC having hard programming unit and in CIC having micro programming unit. Then in RIC, that is reduced instruction set, in this the instruction set is reduced, that is it has only a few instructions in the instruction set. May of these instructions are very primitive. The instruction set has a variety of different instructions that can be used complex operation, means in CIC having means for variety of instruction sets, so they can do the complex operation also. Okay, and in reduced instruction set controller here, the instruction set has a variety of different instructions that can be used complex operation. The complex addressing mode are synthesized using software, and in CISC already support complex addressing mode. So the key difference between RIC and CIC is that the size of an instruction set is small as compared with RIC. In RISC, the CPU control can be done with hardware without comprising a control memory, where CIC is microcode that use ROM. However, the current CIC processor also utilize hardware control. RISC processor work with 32 bits for each instruction and frequently based on the register, while CISC utilize an format that range from 16 bits to 64. Here RSC is using the 32 bit for each instruction set, and here the range of CISC is, that is a 16 bits to 64. RSC architecture includes the design of instruction cache and split data, where CIC architecture includes the undefined cache index for data. Okay, so here the general purpose register used in RSC processor are 32 to 192, whereas RSC uses 8 to 24 GPRS. Okay, so today's lecture over here.